Hey everyone. Recently I was working on an old project that I inherited, and I was making some updates to the application. One of the changes I was making concerned how it handles certain configuration and media files. The application would read some of these files when it was starting up and initializing, and then after that it never read them again until the application was restarted. The issue is these files could be updated in the background by another process. And so we needed for the application to start detecting whenever these changes occurred and automatically pick them up. Now there's a few ways that this could be handled. One is to have the application pull the files just to see whether or not they've changed, but that's inefficient. Another potential solution could be having the user or the application that was updating the files send some message over to the app to let it know that, hey, these files have updated, please reload them. But we didn't use those solutions either. I didn't want the user to change how they were using the application. I wanted this change to be as invisible as possible, and I was only trying to update one of the applications. So the solution I ended up going with is using the file system watcher. Portions of this solution were written in .NET and portions of it were written in Node. Now, both Node and .NET have file system watchers, so here I'll demonstrate how both of them work. Now, what I won't show you, and something you have to figure out for your own solution, is once the file has changed, how does your application best respond to it? And that's going to depend on the specific logic of your application. But here, I just want to show how the file system watchers work. So let's jump into the code so I can show you how this operates. This is part of the source code for the .NET sample. We want to focus on the code within the constructor because this is where I create the file system watcher. The first few lines of the constructor are only making sure that the application is actually running from the same directory in which the executable is placed. If it's not, it'll change there. I go ahead and I load some information that's in the content files, which in this case is just 2 text files. And the only thing I'm doing with this is I'm displaying the contents of the text file on the screen. Now, while the application is running, if either one of these files is changed, it will detect that that file has changed and you'll instantly see it make the update to what's being displayed on the screen. When I create the file system watcher, I give it the directory in which the application is running. So the files it's loading this content from, these are going to be peers of the executable. They'll be right there in the same folder. The file system watcher will accept a filter so that you can tell it what files to look at. If I change this to star.star, then it will look at any file change within that directory. I'm only interested in getting updates on changes to the text files. So in this case, I use star.txt. Now, the file system watcher also has 4 events that you can subscribe to for various types of file changes. For my example, I'm only using the created event, which is triggered whenever a file was created, and the changed event, which is triggered anytime any type of change occurs within the file. Some other options include the deleted event, the rename event, and there also exists an error event. So I'm not using any of those here within my code. Now, there's also another property called notify filter, and you can use this to indicate which file attributes that you're interested in. So I used a few here: creation time, last written, and file name. But there are some others, such as last access, last write, security, and size. After you've set all the properties of interest on the file system watcher, and after you subscribe to the events, the next thing you need to do is set enable raising events to true. Once you do that, as file system events occur, your application will start to get notifications for them. I'm using the same handler for both of the events that I'm subscribed to. Whenever an event occurs, it checks to see the name of the file on which that event occurred. And based on the name of that file, I reload the contents and then I show it on the screen. The rest of the code within this class is just to support data binding so that I can display this on the screen. So there's nothing special here, but let's go ahead and see it running. So here you can see the application is running. It's already showing demo content within it. And I have both of these files open within tabs in Notepad. So if I change contents of a file, and then if I save it, you see the application also updated with those contents. Let's change the other file too, just so that you can see it change. Now it might not be obvious when I'm actually saving, so let me do this again, and this time I'll use the menu so that you can see when the save function is being invoked. So I'm changing to a different title, file, save, and you can see that's pretty much instant. Same thing with the content file. So I'll put something else in here. File, save, and you see the application updated instantly. So that's how the .NET version works. Let's move on to looking how the Node file system watcher works. Here's the entire Node source code, but the part that's important is right here. Using the watcher node is pretty simple. It's a matter of creating a watcher object using the file system object and passing to it the folder that it should be monitoring when it's created. The event parameter here passes a string that identifies the type of change, but it might not quite conform to what you would expect. So here I am running the Node application. Now this instance is monitoring a folder called content. And when I start making changes within this content folder, we'll see the events get raised. So here I create a new text document and it sees that a rename occurred. And also when I renamed it, then that's also raised as a rename event. So let's change the contents within it. That calls a change event to be raised. But let's delete it and see what that does. So that also calls a rename event to be raised. So like I said, some of the events that you get from the Node application might not conform to how you'd otherwise expect them, but it's easy to use. And at least lets you know that the file has been changed, and you can query a little bit more to figure out the exact nature of the change. I hope you found this informative and enjoyable, and if you did, be sure to like and subscribe, and also follow me in these other spaces. I also have a blog on which I put out content, I'd say about every other week, so be sure to follow me there too. Until next time.